Put yourself in a position for an interstellar shocker. According to a gathering of scientists, Betelgeuse, the hypnotizing red supergiant decorating Orion's shoulder, has recently exploded. That's correct. You heard that right. We are completely serious. Inside the next 10 years or a couple of centuries, its marvelous repercussions will illuminate the evening sky. But how did analysts arrive at this conclusion? Should we be concerned? Might the James Webb Space Telescope capture the remnants of Betelgeuse? Today, we're diving deep into all the latest details about perhaps one of the most recognizable stars in the night sky in the Northern Hemisphere during winter. The red supergiant star Betelgeuse. It's among the handful of stars that shine brightly enough for us to see. In fact, its blushing orange tone makes Betelgeuse generally the 10th most brilliant star in the night sky. Anyway, as you may know, it has always been known to vary in brightness. Part of the justification for this is that Betelgeuse is by no means your normal star because of its enormous size. Assuming we were somehow able to replace Betelgeuse with our own little sun, it would stretch out to the asteroid belt and have a mass of a shocking 20 times that of the sun. It may come as a shock, but Betelgeuse is very energetic for a star with an age estimated to be around 8 to 10 million years. In comparison, our own sun is much more settled with a normal age of around 4.6 billion years. This is because very massive stars like this consume rapidly through their nuclear fuel and go supernova relatively quickly on land timescales. This similarly suggests they evolve rapidly, and Betelgeuse may, in fact, have done that right before humankind's eyes. To understand how scientists arrived at the conclusion that Betelgeuse had recently exploded, it's fundamental to dive into the context. The story starts around the 2nd century BC, when Chinese astronomers noted a significant observable fact, that Betelgeuse showed a specific yellow color. Fast forward to the middle of the 2nd century AD, and the Greek astronomer Tycho Brahe described it as orangish or blushing, like how it appears today. Equally, ancient onlookers in the Middle East saw a practically identical tone. The question arises about how colors were named or found in the past. Anyway, for this case, there is a genuine chance that Betelgeuse underwent a color change over the centuries. It is possible that Chinese astronomers knew Betelgeuse during its yellow supergiant stage, and over the years it evolved into the red supergiant stage. Given that individuals by our tendency are night sky watchers, one must consider the number of people across the globe who could see the star and notice the change, but left no records. After all, changes to a star like that likely came with extensive dimming and brightening events that aren't recorded. Imagine them gazing at the night sky and saying, "Hey, didn't that star used to be more brilliant?" And that is exactly what's been occurring right now. Betelgeuse is a variable star. However, it appears to conform to some cyclic behavior. Starting in December 2019, Betelgeuse's brightness unusually plunged, which was clearly noticeable to the unaided eye for those used to checking out the star. It was not its regular self until mid-2020. Over time, it recovered, and one theory was that some of these cycles had fit, making for a particularly deep dive in brightness. At any rate, the observations made by the Hubble Space Telescope showed something rather specific. It appeared that Betelgeuse had expelled a huge amount of burning material into space, forming a gigantic dust cloud. This dust cloud, in turn, obscured a significant portion of the star's light when viewed from our perspective. The change was quite stunning. Betelgeuse, once considered among the 10 brightest stars in the night sky, dimmed to where it positioned lower than the 20th most brilliant. It was truly puzzling to notice its duskiness compared to its adjoining star Aldebaran, which held the 14th position in brightness. Luckily, Betelgeuse offered hints of improvement. However, its strange behavior didn't stop. In fact, it is now exhibiting a state altogether more peculiar than basic diminishing. Over recent months, Betelgeuse has gone through a profound increase in brightness, surpassing its ordinary brightness by a stunning factor. This bewildering situation is quite troublesome for a star known for its changes. The darkening events could be caused by dust or matching cycles, or maybe the star produced enormous sunspots. At any rate, a significant increase in brightness is something different altogether. Despite the way that it might be associated with the previous event, when Betelgeuse expelled material in late 2019, It likely caused a significant disruption in the star's plasma flow. The current behavior we observe could be considered a delayed repercussion of that expulsion. However, what lies behind this extraordinary behavior, outstripping the star's typical fluctuations? One moderate hypothesis that has been widely discussed is that Betelgeuse is moving toward the supernova stage. While moderate estimates still suggest that the star is close to a millennium from the present supernova event, we will provide evidence to investigate this idea and show that it has already occurred. So, what is the evidence? According to a remarkable recent scientific paper by Hideyuki and partners of Tohoku University in Japan, Betelgeuse has already gone through a supernova explosion, and we may be seeing the repercussions of this momentous event in the next 10 years or a couple of centuries from now. Yes, that is right. As surprising as it sounds, the last noted supernova in our galaxy was the Kepler supernova, which occurred as far back as the 1600s. Through an exhaustive evaluation of Betelgeuse's variability patterns, the experts have identified 4 distinct periodic changes occurring over timescales of 2,200 and 420 days, 230 and 85 days, while the beginning of the longest period stays dark. It is assessed to be the urgent period, with the more restricted extents perhaps filling in as clues. The experts propose a model suggesting that Creepy Crawly Jew is in a late period of carbon consuming, surmising that it may be almost a huge shoot, situating it as a prominent competitor for the next anticipated cosmic explosion event inside our Milky Way universe. With respect to unraveling the secret surrounding insect squeeze, there's somewhat of a puzzle. You see, there are some conflicting perceptions with respect to the launch of materials and the star's following recovery. The general agreement leans towards a mass release occasion, something not through and through boundless for various kinds of stars, though on a more humble scale compared to our own Sunday. Yet here is the bend. Supernovae are a genuine article too. We actually saw one in a satellite system of the Milky Way back in 1987. So, while it's possible that our gauges for Betelgeuse's cosmic explosion timing could be off, don't go planning a trip around it now. The precarious part is that insect juice is currently interesting to note. It has slipped behind the sun and won't be evident in the night sky until basically August. In this manner, we're left in the dark about what this enigmatic star ultimately depends on at the present moment. What we cannot deny is that it's kicking its not unexpected patterns by lighting up. Now here's a captivating thing. Betelgeuse's colossal size and somewhat closeness, approximately 650 light-years away, permit us to decide a plate in reality while noticing it. Most stars are only too far away, showing up as simple points of light. Yet, with Scarab Juice, we have a unique chance to capture direct variations in its light output through photography. So, we not only have a star that might potentially go supernova, but also a lot of data to accumulate, including pictures, despite the fact that they may be a bit cloudy. We should envision the situation where Betelgeuse has indeed gone supernova. How should it look? Neat straight? It will be a certified presentation. In any case, don't worry. It's totally acceptable for us here on Earth. You see, insect juice is altogether far away, so it will not actually hurt our planet when it goes supernova. Anyway, it won't be the most splendid object above. Actually, the moon will still rule it by a wide margin, and we shouldn't dismiss the sun. In any case, it would make its own shadows around evening and remain noticeable during the daytime for about a year. Now, here's the interesting part. The cosmic explosion would be perceptible around evening for a long while, constantly vanishing. There might be a brief period where it recovers some of its past splendor. However, eventually, it will continue to blur until the conspicuous shoulder star in the constellation Orion disappears altogether. While this cosmic explosion won't pose any danger to us, it could create some confusion, as some animals depend on starlight for navigation. With an extra brilliant light above making shadows, it could lose them their game a bit. But that's not all. Cosmology itself would face some difficulties. Noticing the night sky from Earth during times when the moon is shining brilliantly can be a bit interesting. An incredibly splendid cosmic explosion would, in any case, simply convolute matters further. Many telescopes would probably be more excited about capturing the cosmic explosion's luminosity than anything else, even if it means changing their observations. In addition, There would be some warning signs before the clear impact, like recognizing neutrinos and gravitational waves from the star. Anyway, here's the focal question. In the event that Betelgeuse has already gone supernova, could we get the leftovers for that? We want to wait for the James Webb Space Telescope to identify the supernova's remnants. So, how long might it take for Betelgeuse to go supernova? We're not totally certain, but it could happen 1 week from now, 1 year from now, or in 100,000 years. In cosmic terms, that is basically identical to right now. All things considered, failing to remember that the light we see from this star is very old, and if it detonated a long time ago, we wouldn't even have some familiarity with it. What do you think? May Betelgeuse have already gone supernova? Or is it simply showing some unusual changes? Let us know in the comments. The James Webb Space Telescope is clearly the best instrument for making these observations. We shouldn't have to wait long before it handles the secret. Besides, for all the work to grasp Betelgeuse's behavior and its implications for stellar evolution, it involves an intricate procedure combining observational cosmology, theoretical modeling, and historical context. This star, well known for its variability and gigantic size, provides an interesting opportunity for cosmologists to study the life cycle of very massive stars and the phenomena leading to supernovae. It's central, first of all, to grasp the significance of a supernova in the broader context of stellar evolution. A supernova isn't just a fabulous event, it's an essential process in the life cycle of stars. These explosions play a crucial role in dispersing heavy elements throughout the universe. The elements forged in the cores of massive stars become part of the interstellar medium and contribute to the formation of new stars and planetary systems. Thus, the study of Betelgeuse and similar stars helps astronomers understand the chemical evolution of the universe and the processes driving stellar evolution. Betelgeuse's looming or progressing supernova event would mark a critical moment in this stellar life cycle. Researchers are particularly interested in the mechanisms that govern the transition from a massive star's final stages to its explosion. Current models propose that as really massive stars, like Betelgeuse, approach the end of their lives, they undergo a series of complex processes, including core collapse and the ejection of outer layers. These stages are characterized by significant mass loss, which can impact the star's brightness and variability. By observing Betelgeuse's changes, scientists can gain insights into these processes and refine their models of stellar evolution. Moreover, the historical records of Betelgeuse's brightness variations and its reported color changes offer significant clues about its past states. Anyway, ancient astronomers' observations, limited by the technology of their time, have provided a framework for contrasting current data. The transition from a yellow hue to a bronzed orange tint over centuries could reflect the star's internal changes and its movement toward a supernova. This historical perspective enhances our understanding of how massive stars evolve and how their life cycles influence their surrounding environments. The potential for Betelgeuse to become a supernova also intersects with our understanding of cosmic events on a larger scale. The study of supernovae helps astronomers examine the conditions leading to different types of explosions, like Type 1 and Type 2 supernovae. Type 1 supernovae are typically the result of thermonuclear explosions in binary star systems, while Type 2 supernovae, like those expected from Betelgeuse, arise from the core collapse of massive stars. Understanding the differences between these events can help researchers unravel the history of our universe and the frequency of such occurrences. Observational challenges, like Betelgeuse's current position behind the Sun, highlight the complexities associated with studying such dynamic celestial objects. All things considered, astronomers use various techniques to monitor stars that are temporarily obscured. For instance, they employ space-based observatories and specific telescopes to track the star's light curves and analyze its spectral data. These methods provide vital information about the star's composition, temperature, and potential for a supernova. Besides, theoretical approaches, including the use of computational models, play a critical role in predicting and understanding supernova events. Scientists develop simulations that incorporate current observations, historical data, and theoretical physics to speculate how a star like Betelgeuse could behave. These models help in predicting the timing and characteristics of the supernova, offering insights into what observers might expect and how the explosion will affect the surrounding space. The implications of a supernova, from Betelgeuse, extend beyond the realm of cosmology. For instance, a supernova of this magnitude would contribute to our understanding of cosmic radiation and its effects on Earth. Although Betelgeuse's distance ensures that it poses no threat to our planet, the study of supernovae enhances our knowledge of cosmic rays and their interactions with the Earth's atmosphere. This information is crucial for understanding space, weather, and its potential implications for satellite operations and communication systems. Ultimately, the possible discovery of Betelgeuse's supernova remains a source of excitement and intrigue within the scientific community. The event wouldn't just advance our understanding of stellar life cycles. It would also captivate the public's imagination. The dramatic visual display of such an explosion, visible for days or even years, would undoubtedly inspire a new generation of astronomers and space enthusiasts. Public interest in astronomical events often fuels educational efforts and promotes scientific literacy, emphasizing the importance of continued investment in space research and exploration. In conclusion, the potential supernova of Betelgeuse represents a significant milestone in our understanding of stellar evolution and cosmic events. The ongoing observations and theoretical work surrounding the star contribute to a broader comprehension of the universe's workings. As we anticipate further insights from the James Webb Space Telescope and other observatories, the study of Betelgeuse continues to provide valuable insights into the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already exploded or is moving toward that dramatic event, its story highlights the ever-evolving nature of our exploration of the universe and the constant mission to uncover its secrets.